Let's start exercises 2.1, and here in the first 10 problems we have to find principal values. The first one is this, sine inverse of minus 1 divided by 2. We start the solution like this. We give this value a name. Suppose it's y. Let y be the principal value of sine inverse of minus 1 divided by 2. Then sine y is minus 1 over 2. But we also know that sine of minus pi over 6 is minus 1 over 2. When we have sine function, the minus comes outside and sine pi over 6 is 1 divided by 2. That's why. And then you recall that the range of the principal branch of sine inverse is this interval. And this value minus pi divided by 6, the angle belongs to that range, and that is why the principal value of this is minus pi divided by 6. This is how you can write the solutions to all such problems. Next, number 2 is cos inverse of root 3 divided by 2. Because you have seen one solution fully, so from this solution onwards I am going to be sketchy. I will show only the mathematical part. So again, you consider that this is something, some value y, principal value. Then cos y is root 3 divided by 2, but you also know that that is equal to cos pi divided by 6. Now the principal branch of cosine inverse function has this range, and this value belongs to that interval. So this is the principal value of cos inverse of root 3 divided by 2. Next, number 3, cosec inverse of 2. So in the solution you proceed similarly. You assume that this is some value y, then cosec y becomes 2. But that is also equal to cosecant of pi divided by 6, which is a value that belongs to this range of the inverse cosecant function, principal branch of the inverse cosecant function. So the principal value is pi divided by 6. Next, number 4, tan inverse of minus root 3. So again we begin the solution by assuming that this is some value y. Then tan y equals minus root 3, which is tan of minus pi divided by 3. Just like the sine function, if you have minus inside the tan function, inside means in its argument, then you can take the minus outside. And you know that tan pi over 3 is root 3, so it's pretty easy. And the range of the principal branch of tan inverse is this open interval minus pi over 2 comma pi over 2, and this value belongs to that. So this is the principal value of this. Next, number 5, cos inverse of minus 1 divided by 2. So in the solution, again cos inverse of minus 1 over 2, let it be y something, then cos y is minus 1 over 2. But this time you have cosine function, and you cannot just simply take minus inside, because from the cosine function minus does not come out. Cosine is an even function. But even then you already know some other trick. Cosine of pi minus theta is minus cosine theta. And for theta you can choose pi divided by 3, because that gives you 1 divided by 2. So minus 1 over 2 will be cos of pi minus pi over 3 or 2 pi over 3, which turns out to be a value that is in this interval. And what is this interval? This is the range of the principal branch of cosine inverse. In these problems you have to remember these ranges, and accordingly you have to figure out this value. So this is the principal value. Next, number 6, tan inverse of minus 1. This one is pretty easy. Easy because figuring out that angle is easy. You see the solution, let this be y, then tan y is minus 1, which is tan of minus pi divided by 4. And you also know that this value belongs to this range. So that's why here the principal value is minus pi divided by 4. Next, number 7, secant inverse of 2 divided by root 3. So in the solution, the angle that we find, if we follow the same procedure, is pi divided by 6. Secant of this is just 2 divided by root 3. But is this our angle? Yes, because this is the range of the principal branch of secant inverse, and the angle belongs to this. obviously it's in this interval and it's not equal to pi divided by 2. So this is the principal value of this. Next, number 8, cot inverse of root 3. Because the input is root 3, so this is the angle you find. I mean, normally if you think of it, because cot pi over 6 is root 3. But also, this actually belongs to the range of the principal branch of cot inverse. So that's why this is our principal value. Next, number 9, cos inverse of minus 1 divided by root 2. We have not done this, okay. That other one was cos inverse of minus 1 divided by 2, not square root of 2. This is a new one. But the solution is similar, of course. The only difference is that here you have square root of 2, there you had 2. So the angle will be different, but everything else is similar. So again you take this to be y, then cos y is minus 1 divided by root 2. Cos pi minus theta is minus cos theta. You have to remember this. So in this case, what should be your theta if you want this value 1 divided by root 2 pi over 4. So pi minus pi over 4 is 3 pi over 4, and that also belongs to this range of the principal branch of cos inverse. So this is our principal value. And finally you have number 10, cosec inverse of minus square root of 2. And the procedure reveals that the value is minus pi divided by 4, because we want minus root 2. And it also belongs to this range of the principal branch of cosec inverse function. There are a few other problems also in this set of exercises that we will solve in the next video on these things.